Before we start our next examples, what I want us to look at is when that ordered pair was 1, 2, that was nice because it was perfectly in the corner of that box. But what will happen is that we're going to have points of intersection in the middle of a box. And there's going to be no guessing on that. Well, is that 0.5? Is it 0.6? Is it 0.6 repeating? There's no way to try and guess if it's in the middle of a box. If it's not on the corner, there's no way of trying to guess. That's one of the many reasons. Plus, some of these lines, if we have really complicated intercepts and slopes, these can be really pain to graph, and they might not even be in those corners of the boxes. So what we have are algebraic solutions where we're going to still be finding the point of intersection. If I want to graph these, I could. And what I'm still looking for is the point of intersection. But what's going to happen here is that I'm not even going to touch graph paper. I'm not even going to attempt to graph these, but I will find that point of intersection. Our first algebraic method is what's called linear substitution. Again, very descriptive names. Linear substitution. The first step, and these are a little bit different from what we are given in the book, but I think they're a little bit more descriptive. What I say is solve for what I call the easiest variable. When we look at, and it can be either equation, it can be x or y. I know last time we kept solving for y, because when we solve for y, that puts it in slope-intercept. That puts it in mx plus b. Well, I'm not trying to graph, so I don't need to put it in mx plus b. I look in either equation, either x or y, and I just solve for the easiest. In this case, this y is going to be the easiest because all I've got to do is minus the x. I don't have to divide by a coefficient. It could have been an x, but both the x's just happen to have coefficients. In this case, I'm just going to minus 2x to each side. And what's nice now, I don't even have to worry about the mx plus b. Where last time I had to concern myself with signs and fractions. Right now, all I've got to do is just get that one variable all by itself. And what I want to do is, if that's what y equals with one equation, just like it says, solve for the easiest, what I'm going to do is substitute that line into the other line. Hence the name linear substitution, is that when I take one line, I'm plugging it into, I'm substituting it into the other line. So what I have is, I still have the 3x plus, I still have the 4 coefficient. And when you substitute, do so in parentheses, I still have the equals 4. I still have the same line, 3x plus 4, but instead of y, I have what y equals in the other equation. I've substituted one line into the other one. Linear substitution. I still have the equals 4. All I've got to do now is solve. In this case, and in most cases, I'm going to distribute the 4. 3x plus, I end up with 24. I end up with minus 8x equals 4. Well, what I want to do is combine my like terms. Negative 5x, take the sign of the bigger number, plus 24 equals 4. Minus the 24 to get my x alone. Negative 5x equals negative 20. Take the sign of the bigger number. Divide by negative 5. Divide by negative 5. I get x equals 4. Well, remember, I'm not done yet. I'm not looking for what x equals. I'm looking for the xy ordered pair where these two lines cross. I'm halfway done. I have found the x. What I need to do now is plug that back in. And what's nice about linear substitution, this is the preferred method for a lot of teachers. I take that 4, and all I've got to do, I've got the other equation primed and ready. All I've got to do, 6 minus 2 times 4, 6 minus 8 is negative 2. My answer, 4, negative 2. Without even touching graph paper, that's what that means. At ordered pair, 4, negative 2, I don't know what these lines look like, and I don't care. They could be increasing, decreasing, steep, flat. I don't care. One thing I do know is that's where they cross. And remember what it means to be the point of intersection. That works in the equations. If I take x and y and plug it in, 2 times 4 is 8, plus negative 2, 6. It works in that top equation. 3 times 4 is 12. 4 times negative 2 is negative 8, plus 12 is 4. This works in both equations. Linear substitution.